Hi.
Hi, is that the efficacious pirate?
Yeah, that's me, Efficacious Pirate, and your Astronomic Avenger. Nice to meet you.
Yep. I'm glad that you can hear me. Thank you for verifying. I've been having problems with the headset, so if you have any issues,
Oh, I didn't hear anything after issues.
all right. So, how's your Saturday morning going?
Oh, well, I wish I could be doing anything else, but we're here, so it's not too bad.
Okay. Okay. Not bad. Um, so have you, just give me one
Sure. I didn't hear anything after one.
interruption. Have you been through one of these prep interviews with interviewing.io before?
Oh, yeah, this isn't my first one.
Okay.
Usually what happens is that I tell people a little bit about my background and the language I'm comfortable with. So I'm still in university, but I'm looking for new grad roles since I'm graduating this year. And that's my
Okay.
background. That's my experience.
Great. Um, so what kind of role are you looking for? Engineer?
Yeah, software
Uh,
engineer.
software engineer. Okay. Any specific area?
Oh, right now just looking for generalist stuff. My
Any role
background.
for?
I
Hmm.
mean, I had an on-site interview coming up with Microsoft, right?
Okay.
That's all. Uh,
That's good.
Background is
All
mostly in
right.
security and machine learning and stuff like that.
Machine learning and AI?
Yeah, I started a long time ago, so not too long ago, but I won a few international competitions, which put my name on on the stage, like $35,000 in one, and it was impressive on paper at least. So that's how I got it.
Mm-hmm. Mm-hmm. That's awesome. And so this is probably going to be, I mean, given coronavirus and everything, it's probably going to be,
The same format, yeah. Oh, I'm sorry, I didn't hear anything after. It's probably gonna be
hmm okay. All right. Let me quickly switch to,
switching to the phone. Hmm? I'm just not feeling very energetic. Sorry.
all right. I am connected back now.
Oh,
So
cool.
hopefully
I can
this
hear you
is,
better.
yeah, I think so
I'll let
too.
you know if I'm having any issues.
Thank you. Okay, perfect. All right. So, do you have any specific goals for this particular mock technical interview that you want to walk through or practice?
I did have a question in mind. Sometimes when I'm doing peer reviews with friends, I bring up a topic that I've been struggling with recently. But part of
Mm-hmm.
the reason I'm having this interview is because it simulates the fact that I won't get to select the problem I'll be working on. So if you have something from before, you can just paste it over here, and we can go through it.
Sounds good. All right, cool. There's a couple of problems I'm going to share with you here. I'm going to start off slow and then I'm going to get increasingly more and more difficult. So hopefully that's okay. So the first question is going to be fairly simple. I'm just asking you to write a function. Post it here. Write a function that takes in two sorted lists and outputs a sorted list that is their union. The first solution that's going to come to your mind is to merge the two lists and sort them afterwards. So this is going to be part A of this question. I'll make it a little bit more complex right after, but I want to kind of go through this in a stepward manner. And also,
right.
one other thing, just checking, since you have a machine learning background, Do you want me to go into like Python questions specific to machine learning?
I don't think that that's necessary right now because the interview that I'm expecting to have will just be a general coding and algorithmic interview. And I haven't
Okay.
prepared for domain, the sort of domain questions that ask about bias, variance, trade-offs, and stuff for a machine learning specific interview. Right now, I'm targeting software engineering roles where knowledge in a specific domain isn't expected. But I appreciate you taking time to ask that out. Right?
Absolutely.
Since this is so simple, I think I'll go into coding right away.
Okay, sounds good.
So we'll say list one equals I for I in range, let's say, 10. And then list two equals J for J in range 11, 20. And now I want to ask some clarifying, just before I dive into it, I want to ask a few questions about these two lists, right? So by list, I'm assuming you mean arrays, right? And
no, I mean list in this case.
Oh, linked lists.
Real.
Oh, all right. So these are linked lists. Okay. Linked lists. All right. And so what comes to mind is that you have the node, and then you have a value, and you have the pointer to the next element. Is that what you have in mind?
That's right. Yep.
All right. So are elements repeated in these lists?
That's a good question. No. Right
so
now,
we only have
in this first iteration, I haven't put in any constraints. In the second time, what I'm going to do is add in constraints of yes, you have to manage duplicates, and then I'll also after that take away the sorting function. Like you can't use the sorting function, right? You have to create your own sorting ability. So I was hoping to take this question step by step even more complex. But if we want to make it difficult and you're okay with that, then let's go with, you have to handle duplicates. You have to have your own sorting mechanism that you develop, as opposed to using the sorting function or even ordering function. Yeah.
So, and these lists, can we assume that they'll fit into memory? I'm sorry,
yes.
I mean to say that are they immutable or are they mutable lists? So can we modify them?
They are mutable. They can be changed. Yeah, you can change.
Right. So class list node, and then init val next self dot val equals val, self dot next equals next. Sorry. Next is a reserved keyword, so I'm just trying to see next ptr equals none. Yeah. All right. So this is my definition of the list now. Right.
Okay.
And so what I'm going to say is, so let's say that I'm going to write this, and so def return sorted get merge list. I'm going to take in two lists, right? L1, L2, and I want to return the sorted list, right? So the union, what format are you expecting? Are you expecting a linked list or are you expecting an array? So sorted list. So this is going to be yeah, so linked list again. Okay. So again, to walk through the algorithm that I'm going to use is I'm going to check the head of L1 and I'm going to check the head of L2. So I'm going to say that the current dot val is going to be the min of L1 and L2, and then I'm going to proceed, right? So file L1 and L2, right? So let's say my result equals list node, and then I will say that result equals result. So right now, result equals none. Let me start with none. And so let's say that temp equals list node, and then the value is going to be min L1 dot val and L2 dot val, right? And it's going to be mm, sorry. So I have this temporary variable which gets me the minimum of these two, which gives me a list node, which, so to draw it out, right? I'm going to switch to a draw column here, right? Can you see my drawings now?
Yeah, I can.
All right. Right, so let's say 1, 3, 5. And this is 2, 6, 8. Right, so my function is just going to say, okay, fine, what's the minimum that I have right now? So I'm going to have a new list, right? And I'm going to enter what's the minimum, okay? And so we'll have L1 starts here and L2 starts here, right? So I want to determine which of L1 and L2 is selected. So I think that instead of using this compact min notation, it's going to be a little simpler if I just handle it case by case, right? So
I think so too.
if L1 dot val is less than L2 dot val, then I just want to L2 L1 equals L1 dot next, and right. So what I want to do is just going back to the drawing tab. I have this. Can you hear me? It's gone silent.
Yeah.
Okay.
I'm here.
So I'll just keep going like this, like this, like this. This is going to be my result. And once I reach the end, then I just reverse the list, right? So that it's still sorted, but in the opposite direction.
Okay. There might be a slight, potentially a delay on my screen because I see you going up to line 40. You're up to line 45, right? Your code is from line 34 to 45. Is that right?
Let's see.
Okay.
Yeah. Okay. Fine. So let's say temp equals result. This way I can just use right. Uh, and then in the end, I want to say result equals
Right.
result dot next after the while loop is over. So yes, um,
That's right.
here, uh, add L1 to the list and continue and move L1 else if uh, so less than or equal to, let's keep less than or equal to, else add L2 to the list and move L2. Right. So right. So now I just want to implement these two operations. But uh, so this is going to uh, be this is going to fail because there's no uh, I haven't given it any value for val, right? Um, but so let me just give it you know float minus inf or just zero, right? Just as a hack, just to get around that. I know that isn't the best solution, but right. So now I just have to um, let's say head result, and then um, temp equals list node uh, one dot val, and okay, so head dot next equals list node and one dot val none. Yeah, right. And head equals head dot next. And so I want to say L1 equals L1 dot next. And then outside of this, I can say that yeah. So copy paste the same code.
Mm-hmm.
Put a val into. All right. So after after a lot more time than that should have taken, I can return a result. Right.
Okay.
So let's walk through this with an example, and I'll provide the example with let's say the same example that I use here, 135. And that's L1. I have 2, 6, 10, 12, right?
Yeah.
And so we'll walk through it. Then we see that we have our result is just 0 pointing to nothing, pointing to null. And then once we get here, we just see that 1 is less than 2. So then it becomes 0 pointing to 1,
Mm-hmm.
right? And again, I don't like the 0, but we get rid of it here anyway, right?
Mm-hmm.
So then L1 becomes 3 into 5, right? And so you progress like this throughout the list until at the end, both of our both L1 and L2 point to none, and so they're just at this endpoint. And
Mm-hmm.
our result is going to be 0 pointing to 1, 2, 3, 5, 6, 12, right? So now I can see that there's an edge case here which you might run into, right? Because you can't compare L1.val and L2.val if you've reached the end of one of those lists,
Yeah.
right? So that's going to be an issue that we need to observe. So let's say that we reach the end of L1, right?
Mm-hmm.
So we can, there's a quick hack around this. So you can say that if L2, if L1, but then this gets messy. I'm trying to think of an element. Let me just write it. If L1, no, if uh, not L1, if not L2, um, hmm, uh, so instead of just taking these, I can just do an empty check, right?
Yeah,
So
absolutely. Cool.
if not L1, then break. If not L2, so no wait. So yeah, so after this, while L1 and L2, I think I should change this to while L1 or L2, but no, that's not going to change the thing. So now, yeah, now one of them is empty, right? So once you get out of this while loop, one of them is empty. So I just check which one is empty and fill the rest, right?
Hmm. Okay.
So
Do you want me to give a hint?
no, not right now.
Oh,
I can figure that out. So
okay.
non-empty equals um, L1 if L1 else L2, right? So I need to put this backing up here, otherwise it's going to be better. So I'm just saying that this is L1 if L1 is not empty and otherwise it's L2. So then I'll say that while empty, empty of val, and then non-empty equals non-empty dot next. and then head equals head dot next. All right. This takes care of the reaching the end of one of the lists, right?
Mm-hmm.
Because
Good.
otherwise you don't run into a problem when you're at 5. Now we should end up with this. And then what I'm saying is that since this 0 is not really part of our solution, we can just say we move the pointer to go to 1, and so by doing result equals result of next, we just solve the trailing 0. Right. So walking through this again, this seems to be good.
How about, did we want to address the duplicates?
Right. So that's why I have this equal to. All right. So I'm saying that if there's duplicate values, that's why I have this less than or equal to. Right. So I'm just picking one of them. So if both of these have the same value, right, then I'll just pick from L1. Yeah. So if you're comparing both that are equal, then you just pick the one from L1.
It'll just pick the one for the empty list at the end, right?
So let's say that L1 is here.
Yeah.
And we have L2 here, right? And let's say that we have even more trees, right? So this is saying that if we found that L1 and L2 are equal, then just pick the value from L1 and advance that forward. Now we see that L1 and L2 are the same. So we still advance L1 forward. Now that we come to 5, 3 is small, so we advance L2 forward. And now that 5 and 6 are there, we take this to the end and it goes forward.
Beautiful.
Yeah.
All right. Good.
It's possible to do with these. Do this with immutable lists. It just takes a little extra memory. Yeah. And you can't do the head up next. Yeah. It's a little ugly, I'll admit.
That's okay. I mean, we're not trying to get to, optimized code necessarily in the first go. But I think this is good.
All right. I think we have time for one more question, unless we want to run through some, run the code as some examples. Yeah.
Well, let's do one more since you mentioned it. How about one with like a binary tree?
All right. Sure.
Yeah. Okay. So I'm gonna scroll down and down to 78. All right. So what we want to, that's the binary tree that we have. You can pretend for a moment that it is pretty.
Sure.
And
I can do that.
Basically what we're doing is, what we want to do is ensure that we get an array at the end, an output array that looks as follows. Line 85. So what you're seeing happen here is that we start at the root and go anti-clockwise. What we're seeing happen is the root being A, we're going down the left flank, so A, B, D, H, you see that? And then from there, we traverse the bottom flank, and that takes us to O, and then it will go up the right-hand side flank, and it takes G and C, does not bring back A. So,
all right.
Go ahead.
What happened to ENS? Just forgotten?
Yeah. No, it's not forgotten. The question here is that you need to get this output of 85, in line 85, right, in this array format. And the assumptions being made in this particular question are that, one, all nodes are letters. Two, you're only printing the boundaries. You are not printing the inside the perimeter.
So printing or adding to the list?
Sorry, would you repeat that?
No, adding them to the list, right?
Yes, adding them to the list. That's right. And the output is an array. And you can assume a standard tree data structure. You will have access to both children left and right.
Mm-hmm.
All of these are letters.
Mm-hmm. Right. So all nodes are letters. We're only adding the boundaries to the array, and there's a standard tree data structure.
Right.
And so the two children at the leaf nodes. So is it a complete binary tree, or can it be? So it's all we can assume that this layer will always be full.
Correct.
All right. Tree is complete. And so we start at the root, and then we have to come up with this. All right. So, for example, if our trying to understand the question here. If our input was like this, right? Then our output would be A, B, D, E, F, G, C.
Correct.
Mm-hmm. All right. So this isn't a simple pre-order, in-order, post-order traversal. But let's see if there's any properties of this that make it easier to, since it's a tree problem, we need to have some recursion. So let's try to do this by hand, just to get a sense of how the algorithm is going to work, right? So we started A, then we went to the left child, right? A, we went to the left child. Then at B, again, we're going left. So what the pattern is that go left until you reach the the bottom layer, until you reach the base case. The base case is that no children. Right? And as long as you're going left, you do that. And so what I'm thinking is that we can go over the entire thing, but we'll have a check. And then what we can do is for adding these, there's no easy way once you're at H to go to I, unless you recurse, right? And then so what I'm thinking of is traverse the entire tree in, let's say, pre-order, but only add to the list if, and then there's three cases in, one, you're doing the first first side of the triangle.
Right.
Two, now you're in the second stage. You just touch an element add the leaves. 3, you are going back up the last side of the triangle. So I think that I can determine this. I can determine this. Now let's think about how we would go about doing this. So um, what properties can we observe here? Mm, goes this way, goes this way. All right. So we're going to need. What the approach that comes to my mind, and is to use a bunch of Boolean flags, and then
Okay.
that will you know determine our control flow.
Hmm.
But for this last
Okay.
one, so let's say that you do A, B, D, H, then you go I, right? Then you go E, J, right? Then you go K. Just thinking of a standard periodic traversal. And then but you want C to be at the end of the array. So
That's there is a definitive order, so you'll have to go left. Right in your case number 1 in line 101, the first side of the triangle is always going to be the left side. The second side of this, the second, action item would be the bottom section, row 83. Then the third will be, the right-hand side. Those are given, it's not going to shift.
So we reach this. So maybe 3 traversals of the tree.
That's
right?
right. Yeah, that's right.
3 traversals of the tree. The first one is going to get all of the, get the left side. The second one will get the middle leaves. So this is going to get A to H. This is going to get I to N or I to O. It depends on the implementation. I to N, O. It'll be easier to get H to O and just remove the duplicates. And this gets A to, this just gets A, C, G, O, and then reverses it.
Right, and remember that end you won't have another A, right? You'll basically just have OGC. Yeah.
O reverses it to OGCA, then truncates the last element.
The
right?
root.
So
yeah.
the root element. Right. So similarly over here, what we can do is A, B, D, H, A, B, D, H, truncate the final element, and this one will just get H, I, J, K, And then at the end, once we finish our three traversals, you know, we'll have these three arrays: the left, the middle, the right, and it'll be ABD, and then this guy HIJKLMNO, and we'll have OGC because we reversed it, right? And then we just concatenate them together, right?
Yep, that's right.
All right. So let's start implementing this.
Let's do it.
So def get triangle root, and so let me just say that I'm going to do the first traversal here, second traversal, and the third traversal. Just writing out the pseudocode so that I know, so that I can keep myself organized going forward. And this is going to be the bring it all together. Right. So let's say that left equals the empty array, and then we need a helper function def left traverser root. Maybe I need to add another method in this finisher. So the base case of this will be if not root. So I'm also going to need to pass in an array. Return array. And then otherwise, I don't need an else here, right? Return left traverser root dot left. Oh, but because we are assuming that this is a complete binary tree, we don't have to deal with a messy case here, right? Root dot left.
We don't have. What's that? Sorry, can you repeat that last statement?
Because we are assuming. So I'm assuming over here that we are dealing with a complete binary tree.
Yes.
And so once we reach the end here, right?
Yeah.
This will have none. So we'll have this. Right? So root dot left and array plus root dot val, or better yet, array. Yeah. So the reason I'm putting plus here instead of array dot append is because I want to pass this array around in memory, but this becomes very very memory inefficient, right? So this changes to return, and I'm going to add array.append root.val, right? So this way, I am trying to modify the original. So I'm passing by reference, right? So I'm just going to be modifying the original left instead of passing left around in the message signature, which it's just going to take too much memory, right? And then at the end over here, I want to say left equals left. So just left up up. It's going to remove our last element, right? So we have truncated the final element, and we are left with ABD. ABD.
Okay.
Now we do our second traversal. Again, I have a tendency to talk when I'm writing everything just because I feel like over
It's
communicating
true.
is better than, you know, uh,
Yeah, definitely helps.
under communicating. Right. So that's metal traverser. And of course, I don't want to forget to call the function. So left traverser, root left. Right. So this calls it, modifies it, and then in the end I pop it. Right. So first traversal is done. Then I want to say leaves, or I'm going to call it middle just to, and we'll call this leaf traverser, or middle traverser, bottom. What's a good name here? Leaf traverser,
Autumn is good.
bottom traverser.
Yep.
I'm writing in middle because
Yeah.
when you think about it in terms of the array, this is going to be the middle of the array. But when you think of it in terms of the tree, this is going to reach the bottom of the tree, right?
That is true. Yeah, it absolutely, you're right that these are capturing all the leaves. So, but I know what you're saying here.
Um, so the condition over here is going to be different. This is going to be just a standard binary tree traversal, right?
Mhm.
And you're going to say that if not root, right? Uh, bottom traverser root dot left r bottom traverser root dot right r. And over here, I want to say that if the root exists, right, but the children don't exist. So if not, now it's complete. So we only need to check one of the children, because everything in this tree except for the leaf nodes are going to have it. But and so if you just check one side, you don't need to check the other side. That's never going to get things. So I'm just going to say if not uh, root dot left. Array dot append root dot val. Right, so this I want to be clear. I'm just checking whether it's if right. So then it goes through the entire. It goes here, So yeah, so it's not going to recurse infinitely because once we hit this, it returns. And now we just want to say that bottom traverser, root, and middle. It left, center, right. Okay. And for the middle, we don't need to do anything with it. Now our third traversal. And it's good. We have 10 minutes left, so I'm just going to write this out. Right traverser, root 3, and right list. Again, this is now, if not root return. And then this is the same as here, so I can just paste that, except I change it to root dot right. Okay. Yeah. And then I call it on this. And of course, over here, I have to reverse it and truncate the root element. So yeah, I'm going to reverse it, then truncate the root element. So right, uh, so right traverser root right equals right, and then this is how you reverse this in Python, and then return left plus middle plus right. All right, so let's walk through this. We're not done yet. We have to take an example and see if it, if this implementation makes sense. In the interest of time, so that we have some time left for feedback at the end, I'm going to use the simpler case that you mentioned with A, B, C, D, E, F, G. Right?
Okay.
And then I can have the feedback at the end. Right?
Okay.
So root is pointing to A.
Good. Yeah.
And then left is empty. And and this is just a definition. In Python, if you're not familiar, we just tend to define functions as functions. So this is just part of the coding conventions, right?
Yeah.
And so we have this left traverser, and then we pass in root, and we pass in this array, right? So we're here, we're good, right? So not check, and then we check out. We go to our left value. So now we have A in our so in the first iteration, we have A inside left, right? Left equals A. Then next we call it, and then we are dealing with this tree, right? B, D, E, right? So we have B, and then we put B inside, and then we put D inside, right? Because we're not ever going to write. So we go B, we go D, and at the end we have A, B, D. However, since we're going to have D inside, excuse me, when we use this bottom traverser, we remove D because we have ABD, and we want to have just AB because we don't want to have duplicates, right? So that's why we have left up. And in the second traversal, we have the middle. Again, just gonna go through this fast. We traverse the entire tree. And so if we want to discuss the asymptotic complexity, because we're traversing over the entire tree, it's O of n, where n is the number of elements in the tree. Or if it's O of 2 to the L, where L is the number of levels, right? That's our time complexity. Our space complexity, well, you can't do any better than ON, again, where n is the number of nodes, because you need to, in this case, yeah, so ON throughout, right? Time space complexity. And then, again, you push this in D, E, F, G, D, E, F, G. And in that order, you're going to push them in because of the traversal that I did with left, then middle, then right. Right? If I did it in another order, then maybe D, E, F, G would be messed up. But thankfully not when you're doing this pre-order traversal. All right. So then we have our third traversal with the right traverser, and then it goes A, C, G. But we don't want A, C, G. We want G, C, and no A. So we reverse it from A, C, G. It becomes G, C, A. Then we pop it to remove the A. And then we have A, B, D, E, F, G, G, and then, oh, okay, but so there's a problem here where this G is double counted, right? So we want to do middle dot pop. good that we worked through it. Middle of pub, it's removed. And now we just have DEF, right, for middle. So AB, DEF, GC, then we concatenate them together and we return that. Right.
Okay.
Check for any stickers, and yeah, I think that concludes the time of the interview. I appreciate any feedback. Of course,
Yeah,
I think that I didn't start off too strong here. I struggled around a bit, but for this problem, I did a little better. That's my opinion.
I think, yeah, over time, you kind of started to see where this was a little bit more complex, right? So I think it was good. You got the time complexity and space complexity absolutely right. And I think you essentially did, one of the things that you could always mention, right? You did it, but one thing to mention would have been like, okay, this is actually using the depth first, algorithm.
Yes, depth first traversal, yeah.
That would, yeah. So, yeah, it'll help you put yourself in a better light if you say that. Okay, so then in this case, you got, the main, you showed a modular approach to problem solving, so that was really good. Because you broke it down into left, the leaf nodes and in the bottom, and then the right section, so that was good. You used all the right, use a pop function, for example. You used all of those right mechanisms to get there, and you entered it finally in the form that we needed it to be. That was also good. You knew which one is the root, and then followed along the lines from the root. So all of these were good things that you were able to complete. You were able to check, look at left and right and check if it's a leaf or not. So all of these were good. Yeah.
So room for improvement. What can I do better?
Here,
I think that I can write a lot faster, I suppose.
Right. I'm just trying to paste my code in there, for example. I actually did it in this form, and you can do this in many different forms, right? But in my case,
this is a static
deck. Yeah, I just did a deck and used the pop functions and I somehow am a little bit more comfortable with append, so that's why I used that one. But same thing, right? Broke it down into traversing the bottom, left, right, all of these, and checked what the expected output should be. So
yeah, this is a big thing, right?
At least I wanted to share that with you. Okay, so I think in the time that we had, the 2 questions that were provided, give me an idea on what level of difficulty did you feel they were?
Easy to medium,
Okay.
Right.
Okay.
Definitely appropriate for the level of experience that I have.
Okay. Okay. So that's good. That's good. All right, sir. Well, do you have any questions for me before we put in feedback for each other in the forums?
I'd love to, but my mind is going blank now. I just want to enjoy.
No problem. No, I know. I've been. Yeah, time for some coffee or tea or something. I get it. Okay. So it's been a pleasure to speak with you, and thank you for giving me the opportunity to be a part of your interview journey. I wish you all the best in your interviews, and give it hell, right? Go rock this interview with Microsoft.